Okay, good morning everyone. So in this presentation, I will explain you about two sample tests of hypothesis with study case MIBA. Next. So in this chapter, we expand the idea of hypothesis testing to two samples. That is, we select random samples from two different populations to determine whether the population means or proportion are equal. With stating a hypothesis into sample hypothesis test, there is no hypothesis. It's a statistical hypothesis H0. And statement of equality is less than or equal to, equal or more than or equal to, and no difference between the parameters of two populations. The second one is alternative hypothesis or complementary to null hypothesis. A statement of inequality is larger or more than, not equal to, and less than. The alternative hypothesis is true when H0 is false. So in here we see that the first one, H0, is mu1 equal to mu2, and the HA is mu1 are not equal to mu2. So this one is for the two tail. The other is for the right side of one tail. And the last one is for the left side of one tail. Next. Two sample tests of hypothesis independent samples. Where assumption that the two populations follow normal distribution, the two samples must be unrelated, that is independent. The standard deviation for both populations must be known. Two sample tests of means known sigma formula is Z equals x bar 1 minus x bar 2 divided by square root sigma square 2 divided by n1 plus sigma square 2 divided by n2. Next. Now we're gonna move to the study case for the example and problem. Next. Quinza Mikba store wants to compare the taste of its noodles with its competitors' noodle products. Quinza Mibak's restaurant uses a handmade method for making its noodle, while its competitors use tools such as machines. The owner of Quinza Mibak restaurant has a hypothesis that their method is better than its competitors because of the authentic quality of the noodles. To test this hypothesis, the owner conducts research with the following test result. Next. As you guys can see on the top of the slide, that is the result, where is the restaurant Quinza with method handmade has an N of 60 and sample size of 80 and standard deviation 10. The other restaurant method with machine and 55 and sample size 75 with standard deviation 9. The solution is first we state the H0 and H1. So for this case, H0 is mu s less than or equal to mu f. H1 is mu s more than mu f. Second, we determine the significant level. So in this case, I choose 0.01. Next, to find the answer, we're gonna use formula z equals x bar 1 minus x bar 2 divided by square root sigma square 2 divided by n1 plus sigma squared 2 divided by n2. And for the critical value is 0.5 minus the significant level 0.01, that is 0.49. So the z value we got is 2.33. Next. So in here, I will explain how to find the z value. On the previous slide, the result is 0.49. So the closest value is 0.4101 on the slide. Has the same row with 2.3, and the top is 0.03. So we calculate the value 2.3 plus 0.03 is 2.33. So the z value is 2.33. Next. Last one, we determine the z is 80 minus 75 divided by square root 10 square 2 divided by 60 plus 9 square 2 divided by 55. The result is 5 divided by square root 100 divided by 60 plus 81 divided by 55. So in here we've got the result is 2.82 and 3. So the compute value of 2.823 is larger than the critical value of 2.33. Our decision is to reject the null hypothesis and accept the alternate hypothesis. To put it in another way, we conclude the other restaurant method is better and faster. Next. Next, we're gonna discuss about two sample tests about proportion. In here, there is two sample tests of proportion formula. That is z equals p1 minus p2 divided by square root pc times 1 minus pc divided by n2 plus pc times 1 minus pc divided by n2, whereas the n1 is the number of observation in the first sample, n2 is the number of observation in the second sample, p1 is the proportion in the first sample possessing the trait, and p2 is the proportion in the second sample possessing the trait, and the last is pc is the pooled proportion possessing the trait in the combined samples. The other one is pooled proportion formula, that is PC equals x1 plus x2 divided by n1 plus n2, where x1 is the number possessing the trait in the first sample, x2 is the number possessing the trait in the second sample. Next. We're gonna find the study case, the example, and problem. Next. So the example is Queen Zamiba restaurant recently hired a new workers on the restaurant. The manager restaurant is particularly interested in whether there is a difference in the proportion of new workers and old workers who will have a better performance work. And a random sample is chosen by the manager of 100 new workers with 19 value in performance. Similarly, a sample of 200 workers with 62 value in performance. Next. The solution, first we state H0 and H1. The H0 is P1 equals P2. H1, P1 not equal to P2. So the state of H0 and H1 is for the two-tail, and the significance level I choose is 0.05. We're gonna find the critical value. The significance level is 0.05 because it's two-tailed. So the significance level, we're gonna divide it by 2 for each tail. So the critical value is 0.025. Next, 0.5 is the half of the area under the curve. The minus 0.025, that is 0.4750. So the z value is 1.96. So in the other side, I'm gonna explain you how to find the z value. So we're gonna look the black circle, that is 0.4750, has the same row to 1.9, and the top is 0.06. So we'll calculate them. The result is 1.96. Next. Next is the chart. On this chart, the critical values are minus 1.66 on the left side, and the right side is positive 1.66. If the compute z-value falls in the region between positive 1.96 and negative 1.96, the null hypothesis is not rejected. If that does occur, it is assumed that any difference between the two sample proportions is due to change. Next. Next is we're going to determine the P1 and P2. P1 is for the new workers and P2 is for the old workers. So P1 is X1 divided by N1 is 19 divided by 100. The result is 0.19. The P2 is 62 divided by 200 is 0.31. The research question is whether the difference of 0.12 in the two sample proportion is due to change or whether there is a difference in the proportion of new and old workers who have the best performance work. Next is we're gonna determine is the full proportion. PC equals x1 plus x2 divided by n1 plus n2. x1 is 19, x2 is 62, and 1 is 100 and 2 is 200. We calculate them and we've got 81 is 0.27. Note that the pool proportion is closer to 0.31 than to 0.19 because more old workers than new workers were sampled. Next. We're gonna determine the Z, that is 0.19 minus 0.31 divided by square root 0.27 times 1 minus 0.27 divided by 100 plus 0.27 times 1 minus 0.27 divided by 200. The result is minus 2.21. The compute value of minus 2.21 is in the area of the rejection. That is, it is to the left of 1, negative 1.96. You guys can see on the slide, on the center picture, the chart. Therefore, the null hypothesis is rejected at the 0.05 significance level. In another way, we reject the null hypothesis that the proportion of new workers is equal to the proportion of old workers who would have better performance at work. It is unlikely that the difference between two sample proportions is due to chance. To find the p-value, we look up the z-value corresponding to 2.21, that is 0.44, 8, 6, and 4. You guys can see on the screen. That is how do we find the p-value is 2 times 0.5000 minus 0.4864 is 0.0136. We times the value and we got the result is 0.272. The p-value of 0.0272 is less than the significance level of 0.05. So our decision is to reject the null hypothesis. Next. In here, I will explain how to get the z-value. The previous slide is telling us about the z-value corresponding to 2.21 is 0.44, 8, 6, and 4. So in this slide, we know that the 2.2 and the up or the top one is 0.01. If we calculate them, the result will be 2.21. So if we make the same row to 2.2 and 0.01, the result of z-value is 0.4864. Next. Okay, that's all from my presentation. Thank you for the attention and have a nice day.